Hi, everyone. In this video, we're going to be talking about our next big counting tool. And so these are called combinations. So what's the deal with combinations? So permutations are about finding the number of ways to arrange things in order. Okay, so a first place or a second place or a third place, where the order matters. If I swap two, that's a different outcome. It's a different thing. So for example, first, second, third, if I've got three people, if I swap A and B and I do B, A, C, then this is a different outcome than that. Okay, what if instead I'm in a case where my order doesn't matter? So as an example, so here's an example where the order does matter. You're at a restaurant with friends and want to order dessert. There are 7 desserts on the menu. And you rank your top 3. How many ways can you do this? Well, in this case, you're ranking your top 3, and so that is arranging things in order. If you say you like the cheesecake better than the brownie sundae, that's different than if you swap them and you say you like the brownie sundae more than the cheesecake. And so the number of ways to do this, I encourage you to try this out, but that's going to be 7 permute 3, which is 7 times 6 times 5, which is 210. So there's 210 ways to rank your top 3 desserts out of 7. And so that's all fine and well and good. But let's say I change it up a bit. So you're at a restaurant. So same thing. With friends and want to order dessert. So the restaurant has 7 desserts and the table wants to order 3. How many ways? So how many sets of 3 dessert? How many ways can you order 3 desserts? Here, it's important, the order. So the order, I'll say, it's confusing because I'm using order twice. The order in which you order desserts, I'll say request, just to keep this less confusing. The order in which you request desserts doesn't matter, right? If you say you want the brownie sundae and the cookie, that's the same as saying I want the cookie and the brownie sundae. So for example, I want the brownie sundae and the cookie. Is the same order, is the same outcome as I want the cookie and the brownie sundae. Just because you chose the brownie sundae first, that doesn't matter. The server is just going to take that order and bring it to the kitchen, and then it'll be ready when it's ready. So it only matters what you're choosing, not the order in which you're choosing it. And so how do we deal with this? We do this with what are called combinations. And so I'll give you the formula. So this is called a combination. So a combination is an arrangement of objects. I'll say a selection of objects where the order does not matter. Okay, and so just like when we're ordering desserts, it doesn't matter if you order the brownie first and the sundae second. Doesn't matter. You're just, unless you're putting in different orders, but if you're putting in one single order and you're saying, I want this and that, or that and this, all that matters is you picked both of those. And so how do we deal with this? And so we have a formula for this, just like, and it's similar to the permutation formula, but different in a key way. So NCK. So this is written as NC, or it's pronounced as NCK or N choose K. I will be saying N choose K. This formula is N factorial divided by K factorial times N minus K factorial. And so it's exactly the same formula as the permutation, except we have this extra K factorial in the denominator. And so this is the number of ways to select K objects from a set of N objects where the order does not matter. Okay, and so let's ask, why is this K? Well, so before we do that, let's answer our question. So answer to the question. So we have 7 desserts and we want to order 3. So this is a selection of 3 desserts from 7, and our order, the order in which we choose them, doesn't matter. And so the number of ways to do this is equal to 7 choose 3. We have 7 desserts, we want to choose 3 of them. And so that's 7 factorial over 3 factorial times 7 minus 3 factorial. And so this is going to be 7 factorial over 3 factorial. 7 minus 3 is 4 factorial. And now we're going to do the same techniques that we've been doing when we've been manipulating factorials. I'm going to partially expand the 7 factorial so I can cancel the biggest factor in the denominator, which is the 4 factorial. So that's 7 times 6 times 5 times 4 factorial. Don't forget the factorial. Divided by 3 factorial times 4 factorial. We cancel the 4 factorials. So that's 7 times 6 times 5. And now I'll expand this 3 factorial out. So 3 times 2. I won't bother writing out the 1 because it doesn't change anything. And I can either realize that 3 times 2 equals 6 and cancel it with the 6 here, or I can do this one at a time. I can do 6 divided by 3 and get 2. And then I'll do the 2 divided by 2 and get 1. And then all I'm left with is a 7 and a 5. So then 7 times 5, which is 35. So there's 35 ways to choose 3 desserts out of those 7. Okay, and so just a brief recap what is this extra k factorial doing down here? Well, suppose we want to choose 3 objects from a list of 5. Order doesn't matter. Okay, and so if our list is A, B, C, D, E, if these are our 5 things, then maybe let's say we choose A, B, and C. So A, B, and C. Well, this is the same as choosing A, C, and B, which is the same as choosing B, A, and C, the same as choosing B, C, and A, which is the same as choosing C, A, and B, which is the same as choosing C, B, and A. So if the order doesn't matter, all 6 of these are the same. So if the order doesn't matter, all 6 of these are the same. And so what we do is, if you listed out all of the permutations, then you've overcounted, right? If I say, okay, ABC is one of my ways to choose 3 things, and BAC is another way, then I'm overcounting because these should be the same thing, and I'm counting it twice. Then I'm counting it a 3rd time, a 4th time, a 5th time, and a 6th time. So permutations, so if you use a permutation, so if you use the permutation formula, you will overcount the combinations. How much, by what factor will you overcount it? Well, you can arrange whatever 3 objects you pick, you can arrange them in any order. And if you rearrange them, then it'll be the same combination, but a different permutation. And so the number of ways you can arrange 3 objects is 3 factorial. And so overcounted by a factor of 3 factorial equals 6. And as we see, there are 6 ways to rearrange whichever 3 we picked. And so this tells us, so in general, n permute k will be greater than n choose k by a factor of k factorial. And so this tells us that n choose, so k factorial times n choose k equals n permute k, right? Because we can take, we're choosing k things, and then we're arranging them in whatever order we want. So we can arrange, the number of ways to arrange k objects is k factorial. And so this tells us if we divide both sides by k factorial, n choose k is equal to n permute k over k factorial. And going from our n permute k formula, this is exactly the same as n factorial over k factorial times n minus k factorial. Okay, let's do one more example. Let's do 10 choose 8. So this is 10 factorial divided by 8 factorial times 10 minus 8 factorial. So that's going to be 10 factorial divided by 8 factorial times 10 minus 8 is 2, so we do 2 factorial. Now I'm going to partially expand this 10 factorial in the numerator. So that's going to be 10 times 9, and I want to expand it so that I can cancel whatever this largest factorial term is in the denominator. So I'll cut it off after the 8, add the 8 factorial, and we're dividing by 8 factorial times 2 factorial. I'm going to cancel the 8 factorials. And so I'm left with 10 times 9 over 2 factorial, which is just 2. I won't bother writing the 1. And now 10 is even, so I can do 10 divided by 2 is 5. And so the only things I'm left with that I haven't canceled are going to be the 5 times the 9, and 5 times 9 is 45. And the way to interpret this, the way we interpret this is there are 45 ways to choose 8 objects from a set of 10 where order doesn't matter. Another way of phrasing that is there are, so from a set of I'll say from a group of 10 people, if I give this a specific context. So from a group of 10 people, there are 45 possible subgroups of 8 people. Okay, so there are 40, if I want to make a group of 8 people, then there are 45 ways to do it. So that's one way to interpret this. Okay, and so we're going to be doing more examples with combinations, combinations and permutations. These will be the two main ingredients, two of the main ingredients in our combinatorial adventures. And we'll also see some similarities and differences between combinations and permutations, not just in the fact that the order matters or not, but we'll see some similarities and differences in their formulas. So that is going to be all for this video.